In this session, we will try to uncover the rest of the operators, logical operators. So these are used to merge or combine more than one condition. So for example, if we want to find out max of two numbers, like say a greater than b, if this is true, then a is the maximum of the two numbers. And if it is false, b is the maximum of two numbers. For example, if we have maximum of three numbers, so then we have to combine more conditions. Like for example, a greater than b and a greater than c, then a is the maximum of all the three numbers. If this is not true, then we have to check if b is greater than c. Then if it is true, then b is the maximum of three numbers. Else c is the greater of maximum of three numbers. So we have logical and the symbol is double and. Then we have logical or, which is double pipes. Then we have logical not, which is a not symbol. And will return true if all the conditions are true, else false. And or will return true if any one condition is true, else false. And not if the input is true, then output is false and vice versa. So let's see some examples on these logical operators. For example, I have true, logical, and true. Then let's take another system of inline with true and false. And let's take another example, something like false and true. And finally, take both false. So with the logical and, we have to see both are true, then it's true. And then one is false, then it's false. And here also one is false, then it's false. Then here both are false, then it's false. Let's see. Let's compile and see how the result looks like. So first is true, the rest of them are false. And this is for an example. Now let's change this and to logical or. So like we discussed, if one is true, then logical OR is true. So only this falls in the last case. Let's run this example. So all of them are true except the last one. This is an OR example. Now let's see the NOT example. For NOT, if it is true, then it's going to be false. If it is false, it's going to be true. So this is going to be false. This is going to be true. Let's execute, compile and execute this. It's going to be false and true. Now let's move on to the next operators, that is bitwise operators. It is used to perform basic manipulation operations on number. The first operator is bitwise and the symbol is single and next one is bitwise or, which is a single pipe, and next one is exclusive or, and the symbol is cap. So we will discuss what are these. So bitwise and return true if both arguments are true, else false. Now bitwise or will return true if any one argument is true, else false. And bitwise exclusive or cap return true if both arguments are in different state, else false. We'll see with examples to get a better understanding. So let's begin with bitwise and. So true and true, it should be true, and true and false, it should be false. False and true should also be false. Then false and false should also be false. We will see the difference between logical and bitwise and in a while. For now, let's execute this bitwise AND. It's going to be true, false, false, false. Let's take an example for or. Let me change this to or, 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 or. And it's going to be true because at least one argument should be true and rest, both of them are false and it is false. Let's execute this. It's going to be true, 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 false. Let's see example for exclusive OR. Change this to exclusive OR, exclusive OR, exclusive OR, exclusive OR. So both of them are in the same state that it's false. Both of them in different state that it's true. Both of them in different state that it's true. Both of them in same state that it's false again. Let's execute this example. It's going to be false, true, true, false. So now what's the difference between bitwise and then logical AND? So for bitwise, say for example, we have condition 1 and condition 2 and condition 3. Then bitwise, it evaluates all the conditions. But for logical AND, condition 1, logical AND, condition 2, logical AND, condition 3, if at least one condition is false, then stop evaluating the rest of the conditions. If one condition is false, then it will stop evaluating the rest of the conditions. Let's see one simple example to understand this difference a little better. Let's say I have an int x equal to 10 and y equal to 15. And I have a condition, say for example, if plus plus x less than 10, and this is a bitwise and plus plus y greater than 15, then x plus plus else y plus plus. So let's print system out print line X and system out print line Y. So since this is the bitwise and, it will evaluate all the conditions. So your plus plus X is a pre-increment, which is 11 less than 10, and plus plus Y, which is 15 plus plus Y is 16 greater than 15. So 11 less than 10, which is false, and 16 greater than 15 is true, but the final condition is false. This evaluates to false. So X plus plus is not evaluated, Y plus plus is evaluated. So now, right now we have 16 in the Y, then plus plus 16 would be 17. Now let's print X. X is having 11, and then let's print Y, and Y is having 17 in this result. So let's execute this example. So compile. Oh, sorry, I need to comment this out. Compile. Sorry. Compile and then execute. So the answer is 11 and 17. In case of bitwise, this is example bitwise and. Now let's change this to logical and. And like I said, if one false is evaluated, then it will ignore all the rest of the conditions. For example, in this case, X is 10 plus plus X is 11, which is less than 10. This is false. So the rest of the condition is not evaluated, and directly go to Y plus plus. And in Y plus Y, we have 15, and Y plus plus will be 16 in this case, because plus plus Y is not evaluated because it is a logical AND. So the output should be 11 and 16. Let's execute, compile, and execute. This time we have 11 and 16. This is the difference between bitwise and logical AND. Now, let's see one more or few more bitwise operators. First one is left shift, which is like less than, double less than. It is used to shift the bits towards left direction. Let's see one example. For example, if I do system dot out dot println 5 left shift 1. So for the left shift, the formula is n into 2. So if it is one time, then we do n into 2 one time. If it is 2 times, like left shift 2 times, say for example, n left shift 1 time, and the formula will be like n into 2. If it is left shift, say for example 2 times, then the formula is n into 2 into 2. That is 2 times. Let's see in this example. For example, 5 shifting 1 time, it's going to be 5 into 2, which is 10. Let's run this quickly. Compile and then execute. So it's going to be 10. For example, if I left shift 2 times, then it's going to be 5 into 2 into 2, which is 20. Let's run this. It's going to be 20. Likewise, we have right shift with 2 greater than or double greater than symbols. And in the right shift, the formula is, instead of multiplying, we have to divide the number by 2. And if it is 1 time, we divide it by 1 time by 2. And if it is 2 times, then we divided it by 2 times. And we just put the integer value out there. Let's see the example to get the better understanding. So for example, 5 greater than or right shift 1 will be 5 divided by 2, and the answer is 2. And if it is 2 times, then have to divide it by 2 times, and our answer will be 1. Let's run this example. It's going to be 2 and 1. Next operator is complement, which is going to be like, for example, the formula is, if I have to see the complement of n, then the answer is negative of n plus 1. For example, I'll take twice complement, and our answer should be negative of 5 plus 1, which is negative 6. Let's execute this program. validate the formula. It's going to be -6. Then we have some special operators. Let's take one example first. If we have let's say 4 plus 3 into 2, the answer will be 4 plus 3 into 2 is 6, and then 10. So we have to follow some precedence before we calculate the answer. So the special operators precedence order will be like this. The first priority will be given to parenthesis. Whatever is inside the parenthesis, it will be evaluated first. Then the next priority is for increment and decrement. Next priority is for complement and then not. Next priority is for multiplication, division, and modular division or percentile. And then next priority is given for plus and subtraction. Then the next priority is given for less than or equal to, greater than or equal to. And the next priority is given for equal to, or not equal to. And the next priority is given for bitwise, and the next priority is given for bitwise exclusive OR. Then the next priority is given for bitwise OR. And the next priority is given for logical AND. Then the next priority is given for logical OR. The next priority is given for conditional operator. Then the least priority is given for assignment operator. With this, we have finished uncovering the operators in Java. I'll stop here and see you in the next.